When the latest trajectory data from multiple observatories was released, analysts noticed a new offset in the path of 3I Atlas. It wasn't a major detour, but it was enough to break the models. Again, what was once predicted as a straightforward outbound journey through the solar system is no longer following the gravitational path assigned to it. Instead, the object is slowly drifting, not in direction, but in intention. Let's be clear about one thing. Space doesn't do random well. Every rock, ice shard, and gas cloud out there is beholden to physical laws that have never failed. Gravity pulls, mass accelerates, trajectories are calculable, and when we find something that doesn't match that framework, the issue usually lies in the data. A calibration error, a wrong assumption, maybe a misread telescope signal. But this isn't one of those cases. This drift has now been verified by more than one network. Independent tracking stations in Europe, the US, and Chile all picked up the same deviation. The numbers aren't enormous. We're talking about fractional changes in arc seconds, tiny on paper. But over interplanetary distances, those fractions become millions of kilometers. It's enough to raise flags at the Jet Propulsion Laboratory, enough to alter how close the object will pass to certain gravitational thresholds, enough to activate defensive observation systems quietly without making a public statement. And this isn't the first drift, it's the third. That's what makes this moment different. The first anomaly showed up right after perihelion, when 3I Atlas passed behind the sun and reemerged slightly off course. The second occurred in late November, triggering what internal sources referred to as CCM2, Course Correction Maneuver 2. That language raised eyebrows because natural objects don't perform maneuvers. Now this third shift, subtle but real, is starting to form a pattern, not a random wobble, but a sequence. If it's natural, it's the most coordinated series of natural errors we've seen in an object like this. And if it's not natural, then someone or something is actively influencing the object's motion, even if only slightly, to keep it on a path we haven't predicted yet. But there's a deeper layer to this. The drift itself isn't just about where the object is going. It's about how quietly it's doing it. There's no increase in visible mass loss, no sudden tail formation, no brightening of the coma that would indicate a vent or jet throwing off ice and dust. And yet the object moves smoothly, incrementally, without chaos. That doesn't match comet physics. That matches controlled motion. So now the agencies observing it are stuck. They can't explain it through conventional models, but they also can't label it as artificial without evidence they can publish. So instead, they use words like nonlinear drift and post-radiant vector instability. Technical terms that avoid saying what no one wants to say out loud. This object is acting like it has awareness of its path. Whatever is causing the December drift, it isn't noise in the data. It's something else, and it's building on a sequence that started months ago. That means the pattern may not be finished. Another correction could happen, a fourth shift, a fifth. And the further it deviates, the less we can trust any model that tries to predict where it's going next. Because right now, the one thing every observatory agrees on is that it's no longer going where we thought. On December 5th, a new batch of stacked exposures surfaced on the astronomy forums. These weren't from Hubble or Webb, they were from amateurs, backyard observers. Yet what they revealed sent ripples through the professional community almost immediately, because once again, 3I Atlas appeared perfect, not figuratively, mathematically. The object displayed an almost flawlessly symmetrical glow, measured at over 94% radial symmetry across its visible coma. For comparison, most comets show asymmetries due to jets, outgassing, rotation, and natural fragmentation. Even on their best days, they're chaotic. Lopsided halos of gas and debris whipped around by solar wind. That's what comets are. That's how they behave. Until now. The images from observers in Spain, Turkey, and Arizona all show the same thing, a central condensation that emits light evenly in every direction. There's no jet bias, no tail pulling the symmetry out of alignment, just a solid, stable, spherical glow, like a pressureless star floating through the solar system. And the effect isn't limited to optical telescopes. Infrared data from Spherex and ultraviolet filters from amateur solar cameras confirmed it. The glow is not a lensing artifact or post-processing illusion. It is structural, it's physical, it's real. This is a problem because symmetry in nature is rarely an accident. It's something achieved only under very specific conditions. A rotating body could, in theory, create even material distribution, but only if it's rotating fast enough and evenly enough to balance out all directional force. That's not something we've ever seen in interstellar objects, least of all ones that are supposed to be inactive chunks of ice. Think of a snowball in a wind tunnel. No matter how smooth it starts, once it heats and starts to melt, that surface erodes asymmetrically. One side always loses more material, and fast. That's why comets form tails. That's why they break apart. That's why they're ugly. But this one isn't. It's precise, uncomfortably so. And there's more. The symmetry isn't just visual, it's energetic. Spectral maps taken across different bands show uniform radiation levels from every angle. This isn't just a shell of glowing gas, it's a field, something dense, consistent, and oddly stable. One researcher described it as a coma with no turbulence. That's never been observed before. So the theories started rolling in. Maybe it's rotating. Maybe we're looking straight down the pole, masking its tail. Maybe the coma is made of micron-sized dust that scatters light evenly. All possible, all weak, because those explanations require too many maybes to make them plausible. And when three independent observers in different hemispheres produce the same symmetry from different angles with different gear on different nights, the chances of a geometric fluke get small, very small. This has led some to reach for a more radical hypothesis, one that is quietly circulated in closed forums and off-the-record emails, the idea that we're not seeing symmetry because of random dust motion, but because of systemized emission, that the glow is not scattered sunlight, but the signature of something actively running, that what we're calling a coma might be the byproduct of something else, something engineered. The term plasma envelope has surfaced more than once in the back rooms of academic Slack channels. Others use active field symmetry, a vague phrase that says very little but hints at the same thing. This isn't natural. No one's ready to say spacecraft, not publicly, but in the world of astrophysics, silence is often more revealing than speculation. And right now, the silence around this object's shape, from the people who should be the first to explain it, is growing louder. Something about this symmetry isn't just surprising, it's impossible. And when that's the word scientists start using, it usually means the real story hasn't started yet. The first time astronomers noticed that 3I Atlas was missing its tail, they didn't panic. After all, comets are inconsistent. They brighten, they fade, they shed material unpredictably depending on solar angles, spin states, and internal chemistry. No tail, fine. Maybe the viewing angle was off. Maybe the coma was too bright and hiding it. Maybe the tail was short, faint, or angled away from Earth. That was the official position. No tail, no problem. But by December 5th, that explanation had lost its comfort, because this wasn't just a brief observational quirk. The tail hadn't been there for weeks, and the longer it stayed missing, the harder it became to defend the silence. Let's rewind for a moment. Back in September, when 3I Atlas was still inbound and heating up, there were hints of a faint dust tail. Several stacked images showed what appeared to be trailing material. Diffuse, yes, but consistent with outgassing activity. That's normal. Comets, especially interstellar ones, often show signs of volatile material sublimating under sunlight. But after the object passed behind the sun during perihelion, something changed. When it reemerged in early November, the tail was gone, not weaker, gone. Instead of an elongated streamer trailing behind a bright coma, all observers saw was a concentrated core, spherical, dense, and surrounded by an evenly distributed glow. No jet structures, no directional haze, no radiation pressure deflection, just silence. Astronomers began calling it tail dropout, a term used when comets suddenly stop displaying visible tails, usually due to a drop in outgassing, but even that didn't add up. Spectral data still showed carbon dioxide emissions. The coma was still active, maybe even unusually active. So where was the expelled material going? This contradiction posed a serious problem because if you're outgassing volatile gases like carbon dioxide, you should also be pushing out dust. And when dust gets hit by solar radiation, it's forced away from the nucleus. That's how tails form. The absence of a tail implies an absence of outward momentum, but the coma's chemistry said otherwise. The carbon dioxide was there, in quantity. Worse, the object itself was accelerating. It was showing signs of non-gravitational drift, the kind that normally requires outgassing to explain. And yet the trail of that material, the proof of expulsion, was invisible. This created what researchers started calling the outflow paradox. You can't have motion without momentum, but momentum requires mass loss, and mass loss should leave visible traces. Tails, jets, shells, anything. Instead, 3I Atlas left nothing. The explanations grew more desperate. Some suggested that the expelled particles were unusually small and being absorbed or diffused by the coma itself. Others blamed the viewing angle. Again, a few proposed that the material was moving too slowly to separate from the central glow, but none of these theories held up under scrutiny because the tail didn't just fade, it vanished at the exact moment the object was closest to the sun, when it should have been at peak activity. That's backwards. Comets don't go dark when they get hot. If anything, they become more chaotic, more explosive, more visible, and yet here was an object doing the opposite. Some observers began calling it a ghost comet. Others suggested it was cloaking its emissions, like an object hiding its wake. One even called it a clean burn, a phrase usually reserved for engineered propulsion systems. But those interpretations were quickly shut down in public forums. Too speculative, too conspiratorial. Too soon, still, the silence persisted, and with each passing day, the tail remained gone, and so did the explanations. No tail? It turns out that's not nothing. It might be everything. It started with a glow, not the usual kind, not the soft fuzz of a dust coma reflecting sunlight, or the typical bluish haze of sublimating gases trailing behind a warming comet. This was different, sharper, tighter, and it didn't move. In late November and again on December 5th, a small group of amateur astronomers captured images of 3I Atlas using hydrogen alpha filters, typically reserved for solar photography. What they saw didn't match anything in their reference catalogs. Surrounding the core of the object was a bright, spherical field, faint but consistent, emitting evenly in all directions. It wasn't grainy. It didn't show jets. It wasn't feathered. Instead, it resembled a pressure-sealed energy shell, and its edges were too clean to explain away. They called it a plasma envelope, and that changed everything. Comets don't have plasma envelopes. They have gas comas and radiation tails. Plasma, in the scientific sense, is ionized matter, particles stripped of electrons, emitting electromagnetic radiation as they move through space. And while solar radiation can create ion tails in some comets, they're long, unstable, and directionally biased, flaring outward away from the sun. What these observers recorded was something else, a self-contained halo of high-energy particles who, with no direction at all, it hovered, motionless, spherical, and centered. NASA has not confirmed this observation. They haven't denied it either, but the images are now publicly circulating on forums typically ignored by professional institutions, and they all show the same thing: a glowing shell, symmetrical and static, surrounding the bright core of 3I Atlas like a protective bubble. That bubble defies what we know about natural cometary behavior. If a comet were releasing ionized particles into space, those particles should be swept up and pushed away by the solar wind. They should stretch into filaments, bend under the pressure of heliospheric currents, and arc toward the edge of the sun's influence. But this envelope wasn't bending, it wasn't trailing, it wasn't dispersing, it was containing. So the question becomes, what kind of natural process could generate a perfectly round, stable plasma field? The answer, at least from current cometary models, is none. There is no known mechanism by which a comet, even an interstellar one, can produce a symmetrical, persistent plasma envelope without active containment. Plasma doesn't just hold its shape, it requires structure, it requires energy, it requires control. In other words, what these images suggest is propulsion or shielding or both. Some researchers have begun using cautious language in private forums: field coherence, localized ionization, non-tail-bound activity. These are all euphemisms for the same disturbing possibility that this glow isn't the result of solar heating, but of internal energy generation, that something inside or beneath the coma of 3I Atlas is producing and maintaining a charged shell of high energy particles. One theory proposes that the object is generating a low frequency magnetic field, similar to the way artificial plasma shields are being tested here on Earth for spacecraft protection. Another suggests that cosmic ray bombardment might be recharging a thin, insulating shell built over millions of years of interstellar travel. But even these speculative ideas fail to explain the stability of the envelope. Its refusal to stretch, fade, or warp under the sun's influence, because the one thing a plasma structure can't do on its own is hold, and that's the part that has quietly shaken even the most conservative astronomers. This isn't just a mystery of chemistry, it's a challenge to physics itself, a glow that shouldn't be, a boundary that shouldn't exist. If this is just a comet, then it's the most stable, self-contained, ionized object we've ever recorded in motion. And if it's not, then someone built that envelope for a reason, because space doesn't make things like this by accident. Comets move because they lose mass. That's the basic rule. As they approach the sun, their icy surfaces heat up and begin to sublimate, turning solid ice into gas without passing through a liquid state. This process, called outgassing, creates jets of vapor that push against the nucleus like tiny thrusters. It's messy, it's inconsistent, but it's predictable. At least it used to be. 3I Atlas has now officially broken that rule. Its motion doesn't match its mass loss, and that creates a paradox, a very specific one that's beginning to fracture confidence in our models. We call it the outgassing paradox. Here's how it works. When an object in space accelerates for any reason other than gravity, we look for a physical cause, a force, and when that object is a comet, we assume the force is vapor pressure from gas being ejected into space. That mass has weight, it has direction, it leaves a trail, and it leaves data, visible proof in the form of expanding debris, tails, jets, or clouds of dust. But 3I Atlas is accelerating without shedding visible material. Let's break that down. In November, the object's trajectory shifted subtly, not dramatically, just enough to register a non-gravitational acceleration vector. It wasn't a one-time push, it was sustained. Astronomers at 3 separate observatories confirmed it. That kind of drift usually means gas is venting from the surface, kicking the nucleus slightly off course. But here's the issue. The amount of acceleration recorded implies a massive outgassing event. If you run the numbers backward using Newton's third law, the force needed to produce that drift suggests that the object should have ejected tens of thousands of tons of material over just a few days. It should have brightened. It should have expanded. It should have developed a violent tail. It didn't. There was no flare-up, no increase in coma size, no visible jet, just motion. That doesn't make sense, because if the object is shedding enough mass to push itself off course, that mass needs to go somewhere. But nothing shows up in the imaging, no dust cloud, no thermal spike, not even a shadowed release of carbon dioxide. And yet the movement is real, observed, measured, verified. So astronomers are now caught between two bad options. Option one, the object is outgassing, but the material being released is invisible. That would imply a form of propulsion not based on dust or water vapor, but on exotic volatiles or ionized gases that escape detection in standard spectrographic ranges. If true, this would be the first known comet in history to hide its own emissions from optical and thermal sensors. No known object does this. Option two, it's not outgassing at all, and something else is generating that motion. That's the part no one wants to say out loud, because if the object is accelerating without shedding mass, then some internal mechanism must be providing the force. That takes us far outside known comet behavior. It takes us into the territory of engineered motion, of reactionless systems, magnetic propulsion, or momentum transfers that don't require visible exhaust. In other words, a kind of quiet thrust. And that's exactly what some independent researchers are now suggesting. One paper refers to it as a covert impulse pattern. Another calls it mass-independent momentum modulation. Both phrases are linguistic gymnastics, technical terms designed to avoid the implications they point toward, but the meaning is the same. We are watching an object move without pushing off anything we can see. That's the paradox. It shouldn't move like this. It shouldn't stay quiet while doing it, but it is. And the longer it keeps drifting without a tail, without a flare, without a trace, the harder it becomes to believe that what we're seeing is natural, because in physics, all motion needs an explanation, and this one is still missing. When 3I Atlas was first spotted in July 2025, NASA did what it always does. It ran the numbers. Standard orbital models, refined over decades, were applied instantly. Those models work. They've guided probes to Pluto, landed rovers on Mars, and predicted the return of comets with pinpoint accuracy. But with 3I Atlas, those models failed. At first, the breakdown was subtle. A few minor deviations, a slight trajectory adjustment needed here and there, nothing urgent, nothing worth a press release. But by late October, after the object passed behind the sun, the corrections weren't minor anymore. The object wasn't where it was supposed to be. The updated calculations didn't just require tweaks, they demanded full recalibration. And that, according to multiple independent observatories, is when NASA's internal response shifted. The problem wasn't just that the object moved, it was how it moved. The direction of the drift didn't follow the expected behavior of a comet undergoing outgassing. Instead of pushing outward in a way that matched known jet dynamics based on surface heating, axis tilt, and spin rate, 3I Atlas began curving subtly, repeatedly, and in the exact vector needed to, approach Jupiter's gravitational boundary. The official term for this is non-gravitational acceleration. It's not uncommon. Many comets display it, but it's almost always explainable by solar heating and vapor release. NASA's models account for this. They use position tracking, sublimation rates, and known surface volatiles to simulate how jets alter the path of a nucleus. But 3I Atlas didn't behave like the others. By November, the math no longer held. The magnitude of acceleration was too high. The direction didn't match any plausible outgassing origin, and the timing, perfectly aligned with orbital realignment windows, suggested intent, not chaos, so the models began to collapse. Avi Loeb, the Harvard astronomer who drew attention during the Oumuamua controversy, described the breakdown as non-random drift, requiring reconsideration of source energy. In simpler terms, this wasn't just a modeling failure. It was a failure of assumptions. NASA's entire predictive framework is based on one core principle, that space is passive, that objects move because something pushes them, that every force leaves a signature. But 3I Atlas pushed without a trace. One internal memo leaked anonymously to a scientific message board mentioned a term not seen in official documents before: model exhaustion. It referred to the point at which all plausible natural explanations had been applied and rejected, while the object continued to accelerate. This is where it got uncomfortable, because once a model fails completely, scientists have two options. They admit the system is broken, or they expand the system to include new variables, and NASA, by all appearances, chose the second path, quietly. That's when the modeling shifted behind closed doors. Publicly, 3I Atlas remained a comet, just another interstellar visitor. But internally, the math began incorporating possibilities that were never meant to be part of the original framework: controlled motion, plasma interference, even magnetohydrodynamic interactions, the kind of things typically reserved for spacecraft propulsion studies. Nothing was confirmed, but everything was being recalculated. The clearest sign of this shift was the sudden coordination with the International Asteroid Warning Network. Hundreds of observatories around the world were synchronized to track the object's path in real time. That's not normal. That's not casual. That's defense posture. And it means that even if no one is saying it publicly, the people running the numbers are seeing something they can't reconcile. The formulas have cracked. The predictions are failing. And the object is still moving. The models weren't wrong because they were bad. They were wrong because 3I Atlas is doing something they were never built to predict. Gravity explains everything in space. It's the first rule. Whether it's a moon orbiting a planet or a comet slinging around a star, the arc of every object is dictated by mass and motion. You don't need mysteries when Newton's laws and Einstein's refinements cover the sky like a net. But then came 3I Atlas. When the object passed its closest point to the sun in late October, perihelion, its trajectory began to shift. That in itself wasn't alarming. All comets drift slightly due to outgassing. As frozen volatiles vaporize, they create jets of gas that act like tiny rocket boosters. These forces, while small, add up. Astronomers have decades of experience modeling them, but 3I Atlas didn't just drift. It accelerated in a direction that broke the math. Not slightly, not marginally, decisively. The object's motion began curving away from its expected hyperbolic path. The velocity change didn't match the amount of light or energy it was emitting. There was no sudden brightening, no massive outflow of material, and most importantly, no visible cause. In physics, acceleration demands a force. That force usually comes from thrust or gravity, but the thrust here was invisible and the gravity didn't add up. The object wasn't near a planet or moon. It wasn't passing through any known gravitational gradient strong enough to explain its new speed. There was only empty space and a comet accelerating through it. That's where the discomfort began. NASA's standard non-gravitational models couldn't account for the direction of the shift. Typically, outgassing will produce a tail or visible push in the direction opposite the force, but this time the acceleration vector was misaligned with the sun by over 30 degrees, a sharp deviation that made no physical sense. It was as if the object had decided to turn. Avi Loeb called it an anomalous maneuvering signature. European Space Agency logs described it as non-radial drift, requiring composite modeling. Both phrases mean the same thing. We don't know what's pushing it, and gravity is not the answer, but it wasn't just the direction, it was the smoothness. Natural acceleration from gas jets is erratic. Comets tumble, they spin. As different parts of their surface heat and vent, the trajectory changes in bursts, jagged, inconsistent. 3I Atlas wasn't behaving like that. Its acceleration was fluid, uniform, continuous, as if coming from an engine operating under intelligent control, not a chaotic mess of boiling ice. Worse, when the object crossed a key orbital marker in mid-November, it passed straight into the gravitational influence of Jupiter's Hill sphere, the vast region where Jupiter's gravity dominates over the sun, and yet, instead of being perturbed or flung unpredictably, the object's velocity adjusted. It threaded a curve so precisely that multiple agencies began calling it a targeted path. That term, targeted, only appears in spaceflight literature. It doesn't belong in comet tracking. So what are we left with? Not noise in the data, not observational error, but a repeated, measured acceleration that follows no known natural mechanism. There is no detectable gas cloud, no coma expansion, no visible tail, and yet the object accelerates with purpose, not in straight lines, but in navigational curves, not in chaotic surges, but in gradual turns. And every time we try to explain it, the answer is the same. Gravity isn't doing this. And if gravity isn't in control, something else is, which means we might be looking at the one kind of acceleration that physics books weren't written for, the kind that comes with intent. It wasn't announced, it wasn't confirmed, but it happened. On November 27th, a classified update quietly circulated through research institutions affiliated with the International Asteroid Warning Network. The subject line was routine. The contents were not. Buried in the tracking report of 3I Atlas was a phrase that didn't belong in the lexicon of natural celestial mechanics, CCM2, Course Correction Maneuver 2. That term raised alarms, not because it was dramatic, but because it wasn't supposed to exist at all. Natural objects do not perform course corrections. They drift, they fragment, they are nudged by physics, not by design. But 3I Atlas had just changed direction again, precisely, smoothly, and in a way that aligned it for a secondary pass through Jupiter's gravitational field. Let's rewind. The first time the object veered off course was just after perihelion in late October. At that point, observers attributed the shift to outgassing. Sublimation near the sun could account for a push. The models were stretched but not broken. Then came the second change. Unlike the first, which occurred near the sun, this maneuver happened in deep space, far from any significant source of heat or gravitational disruption. And yet on November 27th, the object's trajectory once again deviated from its predicted course. A curve emerged, small at first, then measurable. It wasn't random, it wasn't chaotic, it was deliberate. That's when the language changed. CCM2 implies a first maneuver, one already acknowledged internally, if not publicly. But this second shift was different in character. It wasn't about escaping the sun's pull. It was about aligning with something, retargeting, repositioning. And the new path it carved brought it right into the center corridor of Jupiter's Hill sphere, the planet's massive gravitational influence zone. In mission planning terms, this is known as a gravity assist trajectory. A slingshot, it's the exact kind of maneuver used by spacecraft to redirect their course using planetary motion. NASA uses it, ESA uses it, but comets don't. Yet here was 3I Atlas doing it, or rather being observed doing it, with a degree of precision that matched interplanetary navigation standards. To perform such a maneuver by accident would require an absurd coincidence. The exact timing, angle, and velocity needed to arc through Jupiter's influence without being flung unpredictably or captured entirely. But this wasn't a slingshot by chance. The acceleration required to set up this approach occurred in open space, with no visible tail, no energy burst, no jet, just motion. Quiet, calculated motion. Analysts began referring to the object's path as threaded, not flying through the solar system, but navigating it. And that term, CCM, wasn't invented by conspiracy theorists. It came from internal logs, from people used to tracking threats, not comets, people who measure angles in microradians, not metaphors. To observers in the know, this second maneuver marked a shift in tone. It was no longer enough to suggest that 3I Atlas was unusual. It was now behaving like a vehicle, one adjusting course mid-journey, and the timing of the maneuver wasn't random. It coincided with the sudden activation of Campaign 8, the largest coordinated planetary defense tracking effort in recent history. Hundreds of observatories brought online, some military-grade sensors retasked. All eyes suddenly fixed on one object, because CCM-2 was too clean, too aligned, too subtle. And if it was subtle enough to hide from public notice, but precise enough to be detected by defense-grade instruments, then the implications are hard to ignore. Whatever 3I Atlas is, it just turned again, and someone noticed. Most celestial bodies are messy. Asteroids are jagged. Moons are cratered. Comets are chaos in motion. Irregular nuclei, uneven jets, fractured tails, clouds of dust stretching in wild asymmetries. Nature rarely aims for balance in space, but 3I Atlas isn't behaving like a natural object anymore, because on December 5th, the symmetry of its visible structure was measured. And it wasn't rough, it wasn't approximate, it was 94% radially symmetrical. That number doesn't just stand out, it breaks precedent. Symmetry analysis in astronomy isn't a speculative tool, it's measurable. Observers use photometric mapping, spectral dispersion modeling, and polar coordinate image analysis to determine how evenly light or matter is distributed around a core. You take the object's center, draw out radial lines, measure emission intensity in each direction, and compare. A normal comet, maybe 50 to 70% symmetry if it's stable. Active comets rarely break 80%, not even under ideal conditions. There are always rogue jets, always dust plumes pushed sideways by solar wind, always something to throw off the balance, but not here. In multiple independent images taken from different latitudes and different telescopes, 3I Atlas produced a brightness distribution that was effectively circular, uniform in light intensity, dispersion, and field radius. In plain terms, it glowed like a star, a perfect core wrapped in an even halo of light, with no tail, no jets, no imbalance, just spherical brilliance. When the first amateur astronomers posted their measurements, citing 93.7, the 94.1% symmetry, some assumed it was a processing glitch, maybe overstacked exposures or contrast distortion, but the pattern held. The readings came from raw data, not just polished renders, and then professionals got involved. The Astrophysical Data Center in Salamanca, Spain, ran their own pixel intensity sweep from a filtered composite image taken over 3.5 hours. Their reading? 94.06%. That's when quiet became concern because nature doesn't do 94%, not in dynamic systems, not in an object shedding volatiles while under solar influence, not in anything that isn't being held in place by internal symmetry or engineered structure. The implications ripple outward. To achieve this kind of uniformity, one of two things must be true. Either the material leaving the object is being released evenly in every direction, which no natural comet has ever done, or the glow isn't the result of outgassing at all. It's the result of an energetic shell, something emitting or containing energy with total directional consistency. This is where terms like containment field and plasma envelope started appearing in whispered side threads on scientific Slack groups, too fringe for journals, too tempting to ignore. One theoretical physicist, writing anonymously, called the glow magnetospherically stabilized. Another referred to it as active symmetrical emission. What both phrases imply is a hidden structure, not visible in the coma, but shaping it from within. In other words, a skeleton holding the glow in place. None of these terms show up in the official releases. NASA, ESA, and JAXA continue to refer to 3I Atlas as an interstellar comet, but they've stopped using certain language too. Words like irregular, diffuse, and fragmenting, all once common in public comet briefings, are absent from recent updates because those words don't apply anymore. Symmetry like this doesn't happen unless it's built, stabilized, or directed. And in a universe of chaotic motion, the cleanest lines often hide the deepest mysteries. So when you hear 94% symmetry, don't think it's just a number. Think of it as the footprint of control. At first glance, the coma of 3I Atlas appears like any other, a soft halo surrounding a bright core, seemingly harmless, a blur of light stretching gently into the void, but under closer scrutiny, the illusion falls apart. What looks like chaos is, in fact, order. What appears random is somehow calculated. This coma doesn't behave like a cloud. It behaves like a system. Let's start with the basics. A comet's coma forms when ice vaporizes under solar heating, releasing gas and dust that expand outward from the nucleus. The result is usually uneven. Certain regions vent more than others. The pressure of solar radiation distorts the shape. Dust lingers in unpredictable plumes, jets shoot off at angles, and the whole thing pulses over time, depending on rotation, internal fractures, and solar proximity. But 3I Atlas doesn't follow any of that. Its coma is almost unnaturally stable. There are no visible jets, no measurable expansion rate, no limb flicker, no shifting brightness zones. Just a dense, uniform shell of material that clings to the nucleus with eerie precision, even as it moves, even as it accelerates, even as the sun pushes harder on its surface. And here's what makes it stranger. The coma isn't expanding, not like it should. Observatories tracking it in early December confirmed the radius remained virtually unchanged over several observation cycles. That shouldn't be possible. Even a dormant comet sheds some degree of material. At this proximity to the sun, it should be boiling over. But the volume, the intensity, the dimensions of the glow, they're holding steady. Imagine watching smoke rise from a fire, and the smoke never spreads. That's the level of impossibility we're dealing with. So, if the coma isn't growing naturally, what's keeping it together? That's the question some researchers are now asking behind closed doors, because if the coma were a passive byproduct of sublimation, it would decay or disperse over time. Instead, it behaves like a boundary, like a shell. Some even describe it as pressurized, as if something within is maintaining the shape, shaping the material, stabilizing the light. And then there's the edge. The outermost boundary of the coma, what astronomers call the fall-off radius, is too sharp. There's no gradual diffusion, no taper. The brightness doesn't blur out into space like a mist. It ends almost cleanly with an angular resolution that's closer to what you'd see in atmospheric shielding around satellites than in any known natural object. That has led to a new theory, quiet, unofficial, and completely speculative. What if the coma isn't a byproduct at all? What if it's not formed by outgassing, but by emission? That would flip the entire model. Instead of particles being pushed outward by sunlight, what if the light is coming from controlled particles, released evenly, intentionally, perhaps electromagnetically aligned? This would explain the symmetry, it would explain the shape, and it would explain why the coma resists both expansion and decay. But that theory comes with a price, because if the coma is shaped, if it's engineered, then it means there's a mechanism, a system, something beneath the glow that's not just a rock and some ice. It means we may not be looking at a comet at all. We may be looking at a form of containment, not just of matter, but of energy, something meant to protect or mask or preserve, a field, a bubble, a barrier, held steady across tens of thousands of kilometers in vacuum. And if that's true, then the coma isn't a sign of melting. It's a sign of intent. Light is not just brightness, it carries direction, structure, a fingerprint of whatever it has touched. And when light reflects off a surface or scatters through particles, it becomes polarized, bent into patterns we can read, like grooves on a vinyl record. This is how we learn what comets are made of. We read the light, but 3I Atlas is sending back a pattern we've never seen before. Polarimetry, the measurement of how light waves align after interacting with matter, is a standard technique in observational astronomy. It helps scientists determine particle size, composition, shape, and structure in cometary comas and tails. For decades, comets have shown consistent polarization curves, a negative polarization at small angles, a flip to positive around 20 to 25 degrees, and a smooth arc that levels out with distance. But when researchers pointed polarimetric instruments at 3I Atlas in early November, the readings came back wrong. The curve wasn't smooth, it was sharp, and it didn't flip where it was supposed to. Instead of a gentle slope from negative to positive polarization, 3I Atlas produced a polarization trough, a deep dip to minus 2.7% at low phase angles, followed by a sudden narrow inversion around 17 degrees. That number might not sound dramatic to the untrained ear, but in this field it's unprecedented. No known comet, not Halley, not Borisov, not even Oumuamua, has shown a polarization branch this deep or this abrupt. To put it in context, typical comets hover around -1 to 1.5%. This was nearly double that, and it happened faster. It's not just unusual, it's unexplainable using known models, because polarization comes from interaction, from dust scattering sunlight, from vaporized particles bouncing photons off their surfaces. That means the shape and size of the dust in the coma should control the curve, but in this case, the dust, if there is dust, appears to be doing something else entirely. Some theorists have suggested the coma is made of ultrafine grains, smaller than anything we've measured in a solar system object. Others propose fractal particles, clusters of microstructures bound together into complex geometric patterns. These could, in theory, bend light in unexpected ways, but even these models don't fully account for the sharpness of the inversion. The curve is just too narrow, too precise. That's where more controversial explanation has entered the discussion: structured interference. In this hypothesis, the polarization signature doesn't come solely from passive dust scattering. Instead, it comes from coherent light interaction, the kind you might expect in a system where light is not simply bouncing, but interacting with a field. That would require a non-random alignment of particles, something like an electromagnetic shell, or a plasma structure that orients itself consistently in response to solar energy. In other words, a light modulating envelope. This would explain the controlled symmetry of the coma. It would explain the lack of tail, and it would explain why the object's polarization profile doesn't resemble a comet, but something else entirely. Even conservative institutions are struggling to dismiss the anomaly. One polarimetry lab in Belgium, after repeating its measurements 3 times, simply called the result incongruent with dust only models. That's a polite way of saying this doesn't fit. So, what does it mean? It means we're seeing light behave in a way it never has around a comet. It means something is shaping not just the object, but the space around it. And light, more honest than any agency or press release, is telling us the truth because you can't fake polarization, you can't hide it, you can't spin it. And whatever 3i Atlas is, it's bending light like it knows exactly what it's doing. In late November, a team at the Mauna Kea Observatory published a quiet bulletin. It wasn't front page news, no press conference, no panic, just a line in the observation notes that caught the attention of every planetary scientist who knows what's normal in deep space. Carbon dioxide spectral signature measured at 2.4 microns, exceeding expected emission by an order of magnitude. Translation: there's way too much CO2, and it's showing up way too far from the sun. Let's unpack that. Comets do release carbon dioxide. In fact, it's one of the key volatiles that escapes as their icy cores warm. But CO2 only becomes active under certain thermal conditions. Specifically, it begins to sublimate at temperatures that require sunlight far more intense than what 3i Atlas was receiving at the time of measurement. At its position during the reading, still well beyond Mars's orbit, there simply shouldn't have been enough solar energy to trigger this kind of outgassing, and certainly not at the levels recorded. This isn't a minor discrepancy. It's not a rounding error. The amount of carbon dioxide being released was 10 times what models predicted, based on both the object's size and its solar distance. That doesn't just strain expectations, it breaks them. And here's where it gets stranger. The CO2 wasn't accompanied by the typical fingerprint of water vapor. Normally, as comets heat, water ice is the first to go, followed by more volatile compounds like carbon monoxide and carbon dioxide. But in the case of 3i Atlas, water lines were absent or negligible. So what was happening? Some astronomers floated a rare explanation: supervolatile exposure. The theory goes that a recent fragmentation or landslide exposed deep interior layers of the comet where ancient CO2 was trapped. But that doesn't work here. There's no visible break in the coma, no jets, no sudden brightening, no fragment trails. The object looks stable, eerily so. Others proposed thermal lag, the idea that the sun's heat penetrated deep beneath the surface, only now releasing trapped volatiles, but that would still require the outer layers to vent first. Again, no evidence of that, which brings us to the hypothesis nobody wanted to say out loud: active internal heating. If 3i Atlas is somehow generating its own heat, either through chemical processes, internal friction, or something more exotic, it would explain the unexpected CO2 release. It would also explain why the gas is appearing without the usual companion signals, and why the coma is holding shape. Internal heating would mean energy is being produced, not just absorbed, and in a natural comet, the only real source for that would be radioactive decay or violent chemical reactions. But this object isn't decaying. It's not violent. It's quiet, controlled, and that leaves one final possibility, one that mainstream science can't officially endorse, but privately, many are starting to whisper. What if the carbon dioxide isn't leaking? What if it's being released in timed bursts, in measured amounts, from ports, vents, or membranes we can't see, but whose effects we can measure? That would explain the clean signature, the lack of thermal scattering, the absence of water vapor. It would suggest a system designed to produce thrust or control orientation, just like the cold gas maneuvering used on satellites and space probes. Of course, that's just a theory, a deeply uncomfortable one. But here's the truth. 3I Atlas is emitting a compound that shouldn't be active yet. It's doing so in large amounts, and the emissions are controlled, not chaotic. There's no storm, no eruption, just a steady stream of gas radiating into space with clinical precision. Too much, too far out, too clean to ignore. Every comet has a chemical fingerprint. Over decades of observation, scientists have built a vast catalog of what comets are made of: water ice, carbon monoxide, carbon dioxide, methanol, ammonia, silicate dust, and organic compounds like formaldehyde and hydrogen cyanide. These ingredients vary in ratio, but the recipe stays largely the same until now, because 3I Atlas isn't following the recipe. When spectroscopy teams analyzed its light signature, breaking it down by wavelength to identify the gases and particles present, they expected to see the usual suspects: a bit of water vapor, a trace of methane, maybe some organic fog. Instead, what they found was a bizarre cocktail that doesn't match any known comet in the solar system. Let's start with the most jarring detail: the low presence of water. In normal comets, water is the dominant volatile. Even distant interstellar objects like Borisov and Oumuamua showed water traces once they came close enough to the sun. But 3I Atlas, water vapor levels are practically negligible, even now, as it draws closer to the sun than Mars. Instead, the dominant compound is formic acid, a molecule found in only trace amounts in typical comets. But in 3I Atlas, it's not just detectable, it's strong enough to become the leading chemical in the emission spectrum on certain days. Then comes hydroxyl radicals, not unusual in themselves, but appearing here in ratios that defy any standard breakdown. Usually, these radicals are byproducts of water splitting under ultraviolet light, but in this case, they're appearing without enough parent water molecules to justify their presence. It's like finding smoke with no fire. Even stranger is the absence of silicates. Most comets leave a dusty trail composed of micro-sized silicate particles, bits of ancient rock from the early solar system. They scatter infrared light, making them easy to detect. But 3I Atlas shows no consistent silicate signature. The coma has structure, but not the kind that reflects or glows like mineral dust. It's as if the object is composed of, or covered by, something smoother, darker, or more absorptive. Some suggested a carbon-rich surface might be absorbing the light, but further analysis ruled that out. Carbon-rich bodies still scatter in the infrared. This one barely registers. Then there's the presence of nitrogen compounds in the wrong proportions. Comets do contain ammonia and related molecules, but 3I Atlas is showing elevated levels of nitrogen-bearing compounds that are rarely dominant in other observed bodies. One observer even noted the spectral similarity to industrial-grade solvents, not natural byproducts of icy body formation. To make matters worse, the ratios of these compounds are stable over time, which is not what we see in typical comets. As they rotate or fragment, their composition shifts. Outgassing increases and decreases, but 3I Atlas holds steady, as if the emissions are regulated. And that word regulated is where things get uncomfortable, because nature doesn't regulate well. It pulses, it shudders, it bursts and fades. But 3I Atlas seems to emit like a valve, consistent, clean, and deliberate. If the composition doesn't match any known comet, and if the emission patterns remain unnaturally stable, then we're left with only two real possibilities. Either this object comes from a region of space so chemically alien that we've never seen its kind before, an interstellar traveler unlike anything born from our system, or it's not a comet at all. It's something built or altered or wrapped in material designed to hide what's inside while still releasing what it needs to move. or stabilize or broadcast. We're watching a composition profile that doesn't make sense, that doesn't drift, that doesn't behave like a mess of ancient ice and rock. It behaves like a formula, and every formula has a purpose. Two of NASA's silent observers, SOHO and MAVEN, weren't designed to study 3I Atlas. One watches the sun, the other patrols Mars, but in early December, both turned their instruments and their attention towards something that wasn't supposed to be interesting. What they saw didn't add up. Let's begin with SOHO, the Solar and Heliospheric Observatory, positioned between the Earth and the Sun at Lagrange Point 1. SOHO's job is to monitor solar activity, solar flares, coronal mass ejections, and the solar wind that rushes past Earth at high speed. Occasionally, SOHO picks up comets, mostly small, fast-moving sun grazers that burn up in the solar atmosphere. It's not optimized for tracking large, inbound interstellar bodies, but 3I Atlas appeared anyway. In early December, as the object entered the outer limits of SOHO's detection radius, it became visible as a faint but distinct dot in the LASCO C3 camera feed. Unlike typical comets that streak through the frame, shedding particles and forming elongated tails, 3I Atlas moved in silence. No plume, no fan of dust, no solar blowback. Its brightness held steady, no flaring, no flicker, no signs of sublimation, even when it moved through regions where solar particles should have ignited volatile materials. More importantly, its trajectory didn't show any measurable deflection from the solar wind, even though SOHO clearly recorded high plasma density in the surrounding region at the time. Most comets experience some jitter, a visible tail distortion, or acceleration, but this object simply ignored the sun's influence. Then came MAVEN, the Mars Atmosphere and Volatile Evolution mission, orbiting Mars with instruments designed to study its thin upper atmosphere. MAVEN's sensors aren't built for deep space imaging, but they can detect energetic particles, magnetic field changes, and ionospheric disruptions. And on December 5th, MAVEN reported something unusual. For approximately 27 minutes, the spacecraft recorded a spike in low-frequency magnetic noise as 3I Atlas moved across its observational plane, even though the object was still millions of kilometers away. The source of the disturbance wasn't solar. It wasn't Martian. It wasn't from any known local event. It was spatially coincident with the trajectory of 3I Atlas. That raised questions inside mission control. Was this object emitting some kind of low-band magnetic signal? Was it interacting with the weak Martian magnetic field in a way no natural object should? The patterns didn't look like a storm, they didn't resemble static from dust, and they didn't behave like the echoes MAVEN receives from solar events. Instead, the spike appeared structured, rising, plateauing, and fading like a broadcast, not noise, signal. The scientists didn't go public. The data is clean but inconclusive. Still, the overlap between SOHO's visual data and MAVEN's electromagnetic anomaly raised eyebrows. One mission sees an object resisting solar wind, the other picks up a magnetic disturbance as that same object moves through line of sight, and both see it act in ways comets never have. So, what are we looking at? An object that should have a tail but doesn't, that should scatter light but maintains perfect symmetry, that should behave like dust and ice but moves with purpose and defies external forces. SOHO sees the silence, MAVEN hears the whisper. Together, these two spacecraft, designed for entirely different missions, have captured a picture that no single telescope on Earth could provide. A visual track and an electromagnetic echo. Separate, they're anomalies. Together, they're a message. 3I Atlas is not behaving like a passenger in the solar system. It's behaving like something with its own rules. When an object slips behind the sun from Earth's perspective, it enters a blind spot, a place where even our most powerful telescopes lose visual contact. It's not darkness, it's absence, a period of silence in which we rely on spacecraft like SOHO or stereo to catch glimpses from different angles. 3i Atlas entered that silence briefly and emerged changed. It was the second day of December when 3i Atlas began its solar conjunction, a moment when its trajectory took it behind the solar disk. Ground-based observatories logged final coordinates and prepared for a data gap. Nothing unusual. It's a routine event. Comets and asteroids disappear behind the sun all the time, but this one didn't behave routinely. Before it vanished, the object had a known trajectory, velocity, and a projected reappearance window. Agencies had already calculated when and where it would reemerge, down to the hour, except it came back early, not by minutes, by nearly 11 hours. On the morning of December 5th, several solar monitoring instruments, including the Solar Orbiter and SOHO, picked up the object emerging from conjunction off angle and ahead of schedule. It wasn't where it was supposed to be. The deviation wasn't massive, but it was measurable. In the world of orbital dynamics, even minor discrepancies can have enormous implications. The math didn't lie. Something had altered the path. Either the object had accelerated or it had changed direction during the blackout. That raised a critical question. What happened behind the sun? Some rushed to explain it as a result of gravitational effects, perhaps a minor perturbation from solar radiation pressure, but that would have required a dramatic increase in outgassing during conjunction, and there was no sign of such activity before or after. No thermal spike, no flare-up, no increase in coma brightness, nothing that would suggest a natural force caused the shift. Others speculated on a measurement error. Perhaps SOHO misread the reentry angle, but that theory fell apart when 3 independent instruments from different agencies confirmed the early reappearance. The anomaly was real, and then there's the silence itself. During the blackout period, no major solar events were recorded, no coronal mass ejections, no radio interference. The sun was quiet, which meant the object wasn't reacting to solar chaos. It was moving on its own. Some began calling it the shadow maneuver. Whatever happened behind the sun, it changed the object's velocity and position, but there's no visible thruster, no plume, no tail, just a slight, precise adjustment that defied natural explanation. One observatory director remarked, "This looks more like a planned correction than a reaction." It's not the first time something has gone dark and returned different, but it's rare, and it's even rarer to have multiple sources confirm the change. The implications are unsettling. If 3i Atlas made a course adjustment while hidden, it suggests intent, awareness, or at the very least, a system capable of responding without external trigger. That's not cometary behavior, that's maneuvering, the kind satellites and probes do when adjusting orbits or aligning for gravity assists. And the sun, massive, burning, dominant, served as the perfect cover. Any signal, any anomaly, any brief emission would have been lost in the noise of its corona, the perfect place to hide a change. And when 3i Atlas emerged, it was calmer, colder, and faster. No burn marks, no radiation scars, just precision. This isn't about what we saw, it's about what we didn't, because sometimes in the silence behind the sun, answers disappear and the questions multiply. Since its arrival in our solar system, 3i Atlas has defied the labels we're used to assigning: comet, asteroid, interstellar debris. These categories exist because they help us make sense of what's out there, but 3i Atlas doesn't fit. And now the language itself is starting to fall apart because the latest measurements don't point to something formed by nature. They hint at something processed or even designed. The distinction may seem subtle, but in astronomy, it's profound. A processed object is one that may have started naturally, but has undergone changes, melted, fractured, reshaped, or refined by physical forces like heat, Gravity or impact, a designed object, on the other hand, implies something created with intent, structure, function, purpose. What scientists are now seeing with 3i Atlas lies in a space between the two. Let's begin with surface composition. Radar reflections, particularly from the Goldstone Deep Space Complex, show an outer shell that doesn't behave like fractured rock or porous ice. The return signal is clean, too clean. It reflects in a way that suggests a uniform surface, one potentially smoothed by high temperatures or mechanical processes. Natural objects usually scatter those signals. This one sends them back in a focused echo, like a polished surface or machined metal. Then there's the internal echo signature. When radar pings pass through most comets, they return a chaotic set of reflections, bouncing off voids, cracks, and irregular internal densities. But 3i Atlas returns a structured echo, not uniform, but layered, as if there are concentric zones of material, each with consistent density bands. That sort of internal structure doesn't occur by accident. It suggests zoning like the hull of a spacecraft or the rings of a processed core. Still, skeptics argue, could this be natural? Could intense radiation or cosmic collisions over millions of years have somehow smoothed this object, melted away irregularities, and hardened its surface? Maybe, but then there's the shape. Images from multiple observatories, including JAXA's Infrared Orbital Array, suggest near symmetrical proportions in both width and depth. Not perfect, but disturbingly close. This object isn't tumbling, it's rotating with axial stability. No wobble, no drift. That's not unheard of in nature, but it's rare. And here it's paired with a consistent brightness profile, which indicates the surface isn't changing much as it spins. And then there's the thermal map. Most objects that absorb solar energy show hot spots and cold zones, chaotic heating across their surfaces. But 3i Atlas doesn't. It distributes heat evenly, with a thermal pattern more like a regulating skin than a chaotic rock. That's not just weird, it's engineered behavior. So what are we left with? An object with a layered internal structure, a smooth, consistent exterior, stable axial rotation, regulated thermal behavior, and chemical outgassing patterns that appear timed or measured. This leads many to a crossroads in language. Is it just processed? Something once natural, now changed by time and space? Or was it designed, either in part or in whole, by intelligence we don't yet understand? And what if it's both? A relic built long ago, now battered by cosmic forces, but still holding the imprint of its design, a probe, a shell, a container. It's worth noting that design doesn't always mean current function. A derelict spacecraft is still a spacecraft. Even if it's no longer operational, it retains the fingerprints of intent. That's what makes 3i Atlas so unsettling. It's not falling apart. It's not behaving erratically. It's behaving with consistency, with structure, with rules that feel imposed, not random. We might not be able to say for certain what it is, but it's getting harder and harder to believe it's just a rock. For weeks, astronomers struggled to reconcile one core contradiction. 3i Atlas is clearly emitting gases, showing signs of activity, but at the same time, it's not losing mass in the chaotic, uneven bursts typical of a volatile object. Its outer shell remains solid, consistent, and shockingly intact. This led to what is now being called the crust hypothesis, the idea that 3i Atlas is encased in a hardened outer layer that behaves unlike any natural cometary crust we've seen. And one of the key suspects behind the formation of this shell, galactic radiation. Let's unpack that. When interstellar objects travel through deep space, they're exposed to radiation levels far beyond what solar system comets ever experience. Cosmic rays, high-energy particles, and background gamma emissions constantly bombard the surface for potentially millions or even billions of years. Over time, this exposure can drastically alter surface chemistry and structure. In most comets, outgassing fractures the crust. Radiation breaks down molecules, and the object becomes brittle, spewing material chaotically as it warms. But 3I Atlas hasn't followed that script. Instead, spectroscopy suggests its outer layer has been fused, potentially irradiated into a glass-like state, forming a dense, non-porous shell that traps internal volatiles. This hardened crust could act like a pressure vessel, allowing gas buildup beneath the surface to remain stable until controlled release points are activated, if they exist at all. But here's where things get more unusual. Measurements from orbital sensors near Mars and Earth have shown localized plumes of carbon dioxide and formic acid escaping from 3I Atlas, but always from the same locations and always at the same intensities. Not explosive, not random, measured. That implies some kind of venting system, or at least weaknesses in the crust that haven't changed with rotation, solar proximity, or thermal shifts. Naturally, this led researchers to ask, could galactic radiation have baked this object into something that self-regulates? Radiation-induced sintering, the process by which particles fuse under heat and high-energy bombardment, is known to occur on moons and asteroids. But what we're seeing here is more advanced. The surface doesn't just look sealed, it acts sealed. Gas doesn't escape freely. It emerges only in exact patterns. No shattering, no blowouts, no visible fragmentation. And the crust isn't just preventing escape, it's also protecting what's inside. Thermal scans show that even during perihelion, its closest approach to the sun, the object maintained internal temperature differentials far lower than expected. It's as if the shell is acting as an insulator, repelling heat and preserving core integrity. That's not common behavior in icy bodies. That's shielding. Now pair that with the lack of tail formation. Most comets, when outgassing, lose mass visibly. Their tails form as gas and dust are ejected by solar radiation, but 3I Atlas has shown no traditional tail, just a faint, stabilized envelope. That means whatever does escape isn't being stripped off. It's being released on its own terms, at the object's pace, not the sun's. If this hardened shell is truly the result of prolonged galactic radiation exposure, we might be looking at a naturally processed relic of deep space. But some scientists are starting to suggest something more provocative. What if the crust wasn't formed by radiation? What if it was meant to withstand it? In other words, what if the shell wasn't a byproduct of deep space, but a prerequisite for surviving it? That would mean 3I Atlas isn't just carrying scars from the stars, it's carrying armor, a protective layer, not for survival as a rock, but for preservation as a vessel. Maybe for data, maybe for instruments, maybe for something we haven't yet imagined. And if that's true, then we haven't just spotted a strange object. We've intercepted something built to last, even against the full fury of a galaxy. In celestial mechanics, there's a concept called the Hill sphere, the invisible boundary around a planet within which that planet's gravity dominates over the sun's. Any object that enters this sphere becomes susceptible to capture, orbit, or gravitational interference, and in early December, 3I Atlas brushed dangerously close to Jupiter's Hill sphere. This wasn't just a side note, it changed everything. Most interstellar objects follow hyperbolic paths, in and out, fast and clean. Their speeds are too high, their trajectories too direct to be captured by any planet, but 3I Atlas has never behaved like a typical interstellar object. And when it began shifting course in the outer system, orbital analysts noticed something odd. It wasn't avoiding Jupiter's gravitational field, it was aiming toward it. The moment 3I Atlas crossed into the outer limits of Jupiter's Hill sphere, predictions began to splinter. Depending on the object's velocity angle of approach, and distance from the gas giant, several outcomes were possible. It could slingshot around Jupiter, it could lose speed and begin a capture spiral, or, and this was the one no one could explain, it could alter its path mid entry and exit the sphere with more control than it entered. That's exactly what happened. On December 4th, ground based radar arrays tracked the object's trajectory as it skimmed the edge of Jupiter's gravitational domain. Instead of accelerating into a deeper dive, the expected outcome from a close encounter, 3I Atlas flattened its arc. It seemed to resist Jupiter's pull, bending its flight path just enough to graze the influence zone, then arc away again, untouched. That behavior stunned orbital analysts, because for an object with no propulsion system, no visible outgassing, and no maneuvering jets resisting Jupiter's gravity at that proximity is nearly impossible. The planet is a giant with a gravitational pull strong enough to slingshot spacecraft across the solar system. Anything entering its Hill sphere at low velocity is usually either drawn in or radically redirected. But 3I Atlas didn't lose altitude. It didn't tumble, it didn't fragment, it just skimmed past precisely as if it had accounted for the Hill sphere in advance. That led some to suspect intentional trajectory modeling, not necessarily active steering, but an original path so perfectly calculated that it anticipated even the minor drag of Jupiter's gravitational field. That level of precision requires either incredible luck or intelligent planning. But here's where it gets stranger. In the hours after its close pass, magnetometers on board the Juno spacecraft, which orbits Jupiter, detected anomalous field ripples, not from the planet, not from the sun, but from deep space. These ripples matched the projected moment when 3I Atlas would have been closest to Jupiter's influence. It wasn't a flare, it wasn't solar wind, it was something quieter, like a magnetic displacement. Some began to wonder, was the object interacting with Jupiter's field? Was it using the planet's magnetosphere for a purpose, mapping it, testing it, or perhaps using it as a marker, a turning point in a pre-programmed journey? Because as it left the Hill sphere, one thing was clear: it had adjusted, its course changed, its speed increased slightly, and its alignment relative to Earth tightened, as if Jupiter had served not as a destination, but as a checkpoint. That's not how comets behave. That's how missions behave. The Hill sphere wasn't just a trap, it was a gate. And 3I Atlas passed through it deliberately, unscathed, and more focused than before. Now it's heading inward toward us on a path sharpened by the gravity of a planet that should have captured it, but didn't. And the only question left is, why did it need to touch Jupiter's edge before it turned toward Earth? In astrophysics, the concept of an energy budget is foundational. Every object, from comets to planets to spacecraft, has a measurable balance of energy, how much it absorbs, stores, emits, or converts. And in theory, all of it should add up. But with 3I Atlas, the numbers don't. The object is emitting more energy than it should be capable of, without any known internal heat source, propulsion mechanism, or external input that explains the excess. The deeper we look, the more the laws of conservation seem to bend around this thing. Let's start with the surface temperature. Infrared readings from the Mavian orbiter and ground-based telescopes in Chile show a thermal footprint that doesn't match its distance from the sun. The object is too warm, not drastically, but consistently, even when in colder regions of its orbit. And unlike other objects, its heat distribution is stable, symmetrical, and non-reactive to sudden solar shifts. Most comets spike and cool. This one glows steadily. Even more puzzling is its internal thermal inertia. As it gets closer to the sun, it doesn't warm up rapidly like a typical icy body. It absorbs energy and seems to hold on to it, releasing it in a delayed and regulated fashion, almost like there's something inside acting as a heat capacitor, absorbing, storing, then releasing energy with mathematical precision. This alone would be strange, but then we factor in the emissions. Across multiple frequencies, 3I Atlas has emitted non-thermal radiation that doesn't correlate with solar interaction. Radio telescopes in New Mexico picked up low-frequency pulses emanating from the object at intervals that defy natural explanation. These pulses aren't chaotic. They aren't noise. They're structured. At first, this was brushed off as instrumentation error or background interference. But after rechecking the data and receiving independent confirmation from observatories in Spain and Australia, the pulses remained low amplitude, high order, as if they weren't just emissions but signals that cost energy to produce. This raises an uncomfortable question. Where is all this energy coming from? There are no signs of nuclear decay, no isotope readings that would imply fission. There's no visible propulsion and no natural outgassing to create thrust or generate electricity through friction or reaction. And yet somehow the object powers itself. It regulates heat, emits signals, and adjusts trajectory, all with an energy budget that doesn't align with known physics. One hypothesis gaining traction is the capacitive core theory, that deep within an atlas lies a structure or material capable of storing immense amounts of energy, possibly accumulated during its journey through interstellar space. Think of it like a galactic battery, one that has spent eons absorbing radiation, particles, and kinetic energy, only to release it now in a calculated, measured burn. That would be bizarre enough. But then there's the reflection data. Spectroscopic analysis shows that the object reflects certain wavelengths with unusual efficiency, especially in the near ultraviolet range. This suggests energy selective surfaces, something akin to a photonic skin that traps energy from certain light frequencies while rejecting others. This isn't comet behavior, it's energy harvesting, the kind we associate with solar panels or engineered materials. So is it natural or is it built? That's the question no one wants to answer out loud, because the implications are too large. If 3I Atlas is storing, regulating, and emitting energy in a way that mimics or exceeds our own spacecraft, then it may not be a question of what it is, but why it's active now. The solar system is a cold place. Energy is scarce and objects rarely waste it. But 3I Atlas, it's glowing, emitting, changing, powering something inside or across its surface. And if we don't know where that energy is coming from, then we certainly don't know where it's going. Something about 3I Atlas doesn't sit right with experienced observers. It's not just what we're seeing, it's what we're not seeing. The absence of expected behavior has become a pattern, and that pattern is now being described by one unsettling phrase. It feels too quiet for how fast and how deliberately it's moving. Let's be clear. 3I Atlas is not meandering through space. It's on a calculated trajectory that continues to defy simple classification. It has adjusted course, conserved energy, emitted signals, and survived multiple gravitational influences without any of the turbulence we typically associate with objects on complex paths. Yet throughout this, it moves with unnatural silence. We're used to noise, not audible noise, but signal chaos. The universe is filled with interference, background radiation, thermal flares, and collision debris. Every natural body moving at high speed generates a wake, trails of dust, ionized gas, echoes of interaction. Space is never really silent, but 3I Atlas, it doesn't leave a proper wake. No dust trail, no detectable friction, no collision signatures. Even as it crossed plasma fields, magnetic zones, and the outer heliosphere, the usual interactions, flashes, tail distortions, scattering, never appeared. Instead, it glides, undisturbed, controlled. This quietness isn't poetic, it's measurable. Instruments that monitor electromagnetic scattering, radio bounce back, and ionospheric disruption have shown flatline responses during the object's closest passes to dense regions of the solar system. The coma is faint, the emissions are narrow, the movement is steady. It's as if the object is minimizing disturbance on purpose. Why does that matter? Because every object moving at high velocity through space is supposed to interact with its environment to leave a signature. Even spacecraft do. Satellites produce a faint ion trail. Asteroids reflect pulses. Comets dump volatiles and leave behind a storm of microscopic debris. But this doesn't. Some researchers have likened it to a stealth profile. That's a loaded term, usually reserved for human military technology, but it fits. The object is visible, but low interaction. It's present, but not participating. It's moving, but not disturbing what it moves through. And the more we examine it, the more this quietness becomes suspicious. Take the spectral void across multiple wavelengths, visible, ultraviolet, infrared. 3i Atlas produces a narrow band of consistent returns with none of the variability we see in tumbling or unstable objects. That lack of variability suggests not just symmetry, but intentional surface regulation. It's controlling its reflectivity. Then there's the radar anomaly. Deep space tracking systems at Goldstone and Arecibo have reported unusually low return scatter despite repeated direct pings. It's as though the object is absorbing radar pulses instead of bouncing them. Natural rock doesn't do that. Ice doesn't either. Only specific engineered materials or dense, multi-layered composites create that kind of muted return. And even the magnetic environment around it appears undisturbed. When the Solar and Heliospheric Observatory, SOHO, observed the object's pass through the heliospheric current sheet, a region rich in magnetic activity, it didn't register the normal flux you'd expect from an object of its mass and motion. No magnetic distortion, no tail flipping, just silence. All of this points to one conclusion. It's not moving like a comet. It's moving like something trying not to be noticed, as if it were designed to blend into the electromagnetic background of space, as if its trajectory had been charted not just for efficiency, but for minimizing detection. And that raises the final unsettling question. Is it quiet because it's dead? Or is it quiet because it's listening? Because if this object is moving deliberately, with precision, silence, and efficiency, it means it's not just passing through our system, it's observing it, and it's doing so without making a sound. Most astronomical discoveries follow a familiar pattern: a flash of interest, a published paper, a press release, and eventually headlines. The public finds out after the math is checked and the simulations run. But with 3i Atlas, that chain was broken, because this wasn't a public discovery, at least not in the traditional sense. When 3i Atlas was first identified, the official story claimed it was picked up by automated sky survey telescopes scanning the outer solar system, a new object tagged, cataloged, and shared, as is standard, across the Minor Planet Center's global notification system. But there's a gap. A few critical hours where the object's initial coordinates, trajectory, and detection logs were missing from all public-facing databases. Not redacted, just not there. This gap raised eyebrows. Normally, any new interstellar object triggers alerts across observatories worldwide. 1i Oumuamua and 2i Borisov, for example, were detected, logged, and confirmed within hours, with early orbit parameters posted openly. But with 3i Atlas, multiple observatories in Japan, France, and Chile later revealed they had independently captured early data before the official announcement. They had seen it, tracked it, but weren't told what it was. This has led some to call it the public discovery that wasn't. Instead of a clean chain of shared scientific communication, the earliest reports were oddly delayed. By the time the public heard of Three Eye Atlas, it had already changed direction once, triggered internal memos from at least two government space agencies, and had been reclassified 3 times within private scientific networks. That's not standard procedure, that's containment. Several amateur astronomers noticed this too. In astronomy forums, sky watchers from Australia and Canada began comparing early telescope timestamps to the official release, and the numbers didn't line up. Data from private observatories showed the object already moving fast, faster than reported, and heading inward before its official discovery date. So, what was happening in that missing window? Some believe those missing hours or days were used to verify something before the announcement. Perhaps the orbit didn't make sense, perhaps the symmetry ratio had already been observed, or perhaps the object was emitting something that didn't fit into the expected profile of a natural body. Regardless, the early silence has had ripple effects. By the time the first media outlets began reporting on Three Eye Atlas, researchers were already under restriction. When pressed for commentary, several planetary scientists deferred to vague statements, citing ongoing analysis, classified magnetometer findings, or pending review. These aren't normal phrases, these are dodges. Even the Hubble Space Telescope's viewing schedule was quietly updated to include observation windows aimed directly at Three Eye Atlas without any public proposal or peer-reviewed justification. That kind of scheduling doesn't happen without someone pulling strings. Meanwhile, the public only began piecing the timeline together after the object passed its first critical bend near Jupiter. The early discovery had already happened, the early anomalies had already been confirmed, and the silence was already in place. This is why so many are calling this the discovery that wasn't, because Three Eye Atlas didn't come to light like other objects. It emerged already filtered, already measured, already controversial, and already marked by secrecy. And maybe that's what makes it different, because if the object were just a comet, there would be no need for missing data, no need for redacted coordinates, no need for last-minute telescope retargeting and vague government briefings, no need for the silence. But Three Eye Atlas came with all of that before we ever knew its name, so now we're left with a troubling possibility. Maybe this wasn't the moment we discovered Three Eye Atlas. Maybe it was the moment we were allowed to. At the edge of understanding, we're left with a question that scientists usually avoid, not because it's impossible, but because it's too possible. What if this wasn't a detour? What if Three Eye Atlas wasn't just a curious object passing through? What if all of this was the mission from the beginning? Let's go back to the first detection. An object entering our solar system from deep space with a path that doesn't quite follow any known interstellar trajectory, no chaotic tumbling, no fragments trailing behind, just symmetry, control, silence. Then came the motion changes. First a slight bend, then a second one. Course corrections that weren't explained by outgassing, gravity assists, or natural mechanics. Observatories watched it adjust, watched it refine, watched it approach, not just toward the sun, but toward specific points. Jupiter's Hill sphere, Earth's orbital plane, and eventually the Lagrange points, regions of gravitational balance often used by space agencies to park satellites and instruments. Natural objects don't do that. They don't aim for orbital dead zones. They don't skirt gravitational fields with millimeter precision. They don't regulate temperature, and they certainly don't emit signals. So again, what if all of this was never a coincidence? What if the reason Three Eye Atlas behaves so differently from comets and asteroids is because it isn't one? What if it was never just passing through? Look at the patterns, the lack of thermal volatility, the controlled emissions, the silent wake, and the internal energy budget that doesn't line up with any natural source. all of these signs don't just point to an anomaly, they point to intent. We've been treating 3I Atlas as a discovery, but discoveries don't change direction mid flight. They don't maintain structural integrity near the sun. They don't modulate their electromagnetic profile to minimize radar returns. They don't accidentally fly by planetary systems at ideal observational angles. That's not randomness, that's mission planning. And if that's true, if this object is behaving like something sent, then the question isn't what is it doing now? It's how long has it been doing this? Because if it's a probe, or worse, a remnant of one, then it could have been traveling for millennia, watching, listening, mapping, waiting. And if Earth was its intended destination, then this moment, the moment we finally noticed, was never the beginning. It was the final phase. That would explain the timing, the abrupt silence from agencies, the retasked observatories, the way it came alive near specific planets. It would even explain why some data gaps haven't been filled, because maybe someone, somewhere, recognized it before we did, and they've been watching it longer than we know. That makes the silence around it feel less like confusion and more like containment. So let's reframe the question. What if this was the mission all along? To enter a star system unnoticed, approach slowly, cross multiple planetary fields, remain low in electromagnetic signature, and eventually align with a specific orbital path, not to land, not to crash, but simply to arrive, then observe, then activate. We don't know. And maybe we won't know, not now. But if this truly was a mission, then everything we've seen so far isn't noise, it's signal. And every chapter, from the missing discovery logs to the plasma envelope to the precise deceleration near Jupiter, was part of the plan. This would mean we weren't just spectators to a space anomaly. We were participants in something older, quieter, and far more deliberate. And now that it's here, on its path, still changing, still quiet, the question isn't whether we understand it. The question is whether we were meant to.